All right, so welcome everyone to our July potpourri. About a week ago, I wasn't sure we were going to hold the meeting, but then we like to give a preview to the Starfest event, and I thought that it would be best that we hold it and give John and Leslie a chance to preview the event and then get the video up on the website so that anybody who's considering going will be able to review it. So we have a couple presentations before the Starfest. John Boyd, actually longtime member, great to see him and Darren at the picnic, approached me about a little project he was working on, and radio astronomy has always fascinated me. Way back when I visited the Algonquin radio telescope, and it was so cool to see the. We actually were able to get up and walk on the surface of it, and it was like walking on a screen door. I mean, it's just amazing that the frequency of light of radio waves would bounce off something with holes in it. And then I've actually had the chance to visit a couple other facilities like Penticton out in BC. And it's very cool to see what a radio astronomy is about. And I'm going to have to mute some people here. And I know that there are ways that people can actually set up amateur astronomy setups from an amateur point of view. But I know nothing about it. So when John approached me about talking about this, I thought this would be a great thing to start to talk about, and it should be something that maybe the club can invest in and set up, even if you just capture the Milky Way coming across the sky or Jupiter or whatever. I think it would be a great project. So John, it's all yours. Interested in hearing about your ideas regarding amateur radio astronomy.
Great. Thanks very much, Randy. And let's see if we can actually get this thing up and running. Well, I think we're in business. Everybody can see that?
Yeah, looks good.
Okay, great. Well, like Randy, I've had an interest in radio astronomy for at least the last 20 years. But the idea of being able to look at the universe using part of the electromagnetic spectrum that didn't involve light has always kind of fascinated me. But not being a radio ham or really having access to a lot of radio equipment, let alone the knowledge of how to put something together, so you could actually look at something using the EM spectrum, was well beyond me. So my interest remained rather academic. But over the past 10 to 15 years, there's been a bunch of changes in electronics and the way it functions, and a bunch of changes in radio receiving equipment. And it now appears feasible to do a limited amount of amateur radio astronomy. And so I got an interest in maybe doing something along this line a number of months ago. And as Randy mentioned at the picnic, I mentioned this to him, and he said, "Well, why don't you do something about it and see if anybody else has any interest?" So here it goes. This is a very quick look over about 15 minutes of some of the things that I found out when researching this particular area. I guess it's best to approach the subject by contrasting the visual astronomy that everybody here is used to practicing with radio astronomy, because there are a lot of parallels, a lot of areas that are of interest, and a lot of things that are different in radio astronomy. And maybe I can get your head around the concept of amateur radio astronomy by talking about some observation for the video side is a fairly narrow spectrum of colors from I guess the high end of the ultraviolet right through to infrared. And that's a fairly narrow zone of observation, which I'll show you in a graph in a minute. In the case of radio astronomy, the windows are different and very much bigger. So there's far more range of wavelengths that you can use in radio astronomy than there is in visual astronomy. We suffer from the same problems, however, that visual astronomy is cursed by noise generated by man in the form of light pollution. And similarly, radio astronomy has the same sort of problem, that there are lots of competing emissions that you have to get rid of in order to see the things that you want to see. And of course, you have a big disadvantage because in the case of video astronomy, you've got the Mark I eyeball, which is a good light sensor and tells you whether circumstances are right for looking at the stars. You can see the light pollution, so you know that it's there. In the case of radio astronomy, we don't have an installed sensor, so we don't really have any intuitive understanding of the contamination that might be affecting our experiments. So we have to rely on other instruments to do those measurements. Third item, I guess, is that equipment is very widely available for visual astronomy. No matter what you want to add to your kit, you can usually find 5 or 6 manufacturers that'll produce it for a not unreasonable sum of money. Whereas in the case of radio astronomy, there's a much greater dependence on doing it yourself. In the case of visual, it's all about the mirror or lens and the camera or sensor. In the case of radio astronomy, it's all about the antenna and the radio. And you can really get an idea of what radio astronomy is like by recognizing that what you're dealing with here is really a single pixel sensor rather than a whole suite of them as we have in our CCD cameras and so on. In visual astronomy, we're detecting the thing we want to look at directly. We're looking directly at a cluster or directly at a galaxy or whatever. And in a radio astronomy, we have those direct observations, but we also have indirect detection because some of the things that we can look at are effects that are caused by radio emissions, but aren't necessarily an object that you look at directly. Maybe it's the way the radio effects have an impact on the Earth's ionosphere, and you actually measure the change by looking at the ionosphere rather than looking at the object in question. The big advantage, of course, is that visual astronomy is a nighttime activity, as we all know, and radio astronomy is pretty much an anytime activity. So in that, it's very much different. I'd like to have a quick look at this figure, which anybody who's looked into the subject will have seen before because it shows up on just about every presentation that I've looked at. But there's no attribution ever for it. So I'm not sure who produced the chart in the first place. But on this end of the spectrum, going from 1/10 of a nanometer to maybe 100 nanometers, we're looking at a completely blocked out area of observation consisting of gamma rays, X-rays, and also the far ultraviolet area. Then we get into the narrow bit here where we all operate in our visual astronomy. And then once we're past that, we're into the infrared spectrum, which has areas which are transparent and areas which are not transparent. Then we get into the rest of the infrared spectrum, which is affected strongly by atmospheric absorption. And then once we're through that, we're finally into radio waves, and we can go from about 2 centimeters through to about 15 meters. That's the range of wavelengths that everything's observable directly through the radio spectrum. Once we're past that, we have to look at indirect observations, either through a satellite or alternatively through signals that get bounced around by the atmosphere, by the ionosphere. And ionosphere is important for radio astronomers, partly because it blocks a certain range of the waves that we want to look at, but partly because it permits radio waves to bounce back and forth between the surface of the Earth and this layer of gas in the upper atmosphere. So once you get lower than about 30 megahertz, you're into something that gets trapped in the ionosphere. And this gives us two kinds of observations which are important. One of them is the observation of meteorites, because typically the way it works is you tune your radio into a station that's too far away to actually hear directly. But when the meteor goes through the atmosphere, it leaves an ionization trail. And all of a sudden that radio transmitter can bounce off the trail and down into your radio, and you can detect the presence of a meteor that you couldn't detect before. So the ionosphere, while it blocks our direct observation of a lot of the radio spectrum, is also very useful in doing other kinds of observations. And I think I also mentioned that emissions from the sun and from Jupiter actually have a direct influence rather on the ionosphere, and you can see that influence. You can measure that influence. As you can see from this figure, there's 4 layers of the ionosphere, but once you're into night, those 4 layers collapse into a single layer, and that complicates and makes more interesting the whole study of those particular wavelengths. So I mentioned at the beginning of this presentation that a bunch of things have changed in radio astronomy in the last 10 or 15 years. And those changes are primarily in radio equipment and the availability of radio equipment. And it's the arrival in the last decade of low-cost software-defined radio, low-noise, high-frequency amplifiers, and better high-frequency filters that make it possible for an amateur to do things that only a professional could do, and with extreme difficulty in the past. And those changes make it feasible for us to do a certain amount of experimentation ourselves and at a fairly reasonable price. Many of these devices that we can use were invented for a completely different purpose. And we're basically just using them for something they weren't intended to be used for. Improved availability of dish antennas, really through a period of time in which satellite antennas were used to pick up TV, the presence of, or the availability of high-speed computers so that we can use software-defined radio. And I think also a greater appreciation of radio astronomy as being more widely understood in the public interest, and perhaps leading to more amateurs willing to give it a bit of a chance and do some experimentation on their own. I mentioned a software-defined radio. In a normal radio receiver, there's a detector and an amplifier, followed by a whole series of analog stages that act on the radio waves that are received so that you can get what you want, whether it's a sound of a program or whatever, out of the end of the radio. Well, these days, they're replaced by a wideband amplifier, a digitizer, and then a whole bunch of digital operations that were carried out by the average home computer. And this has resulted in a very much higher precision and wider bandwidth radio than was ever available 15 years ago. Practical SDR implementations awaited the availability of high-speed digitizers, because you're talking about digitizing at a rate of about 10 or 20 megahertz, and readily available personal computers that had the requisite speed as well. These devices are available in the form of a USB stick size device for as little as Canadian $30 to $50 for 8-bit implementation. And this came about because people discovered that a chip that was invented in 2012 for a USB TV dongle would work equally well for a broader range of the radio spectrum. The particular one that I have is a little bit bigger than that, but it's still nevertheless a small device. This is an SDR radio, and it's pretty simple and straightforward to operate and to use to do some sleuthing in the radio spectrum. What kind of experiments can you carry out with a radio telescope? Well, it depends on the radio band. From about 30 hertz to 300 kilohertz, there's things called tweaks, whistlers, and spherics, which are basically a result of lightning, auroras, solar ionosphere activities, and so on, followed by SID, sudden ionosphere disruption, where changes that happen on the surface of the sun, mainly mass ejections and flares that send out charged particles towards the Earth and hit the magnetic field around the Earth, and thereby change the position and conditions of the ionosphere can be picked up by a radio telescope. So here we are looking at something which is not the direct subject we want to look at particularly, but is the consequence of that direct subject. And it's also possible to put in place these days fairly easily the sort of magnetic sensors of the Earth's magnetic field that would actually measure the impact of these solar activities as well. In the 3 to 30 megahertz band, you can listen to Jupiter singing away. You can look at solar effects, and some folks have actually looked at pulsars as amateurs as well. 30 to 300 megahertz, that's where the area of FM meteor detection comes in. I talked about that before, where you tune yourself into a radio station that's too far away to hear, and the effect of the meteor going through the atmosphere is to create a vapor trail that can be used as a reflector, and all of a sudden that radio station that you couldn't hear before is available for you to monitor. And you can infer lots of things about the condition of the meteor depending on the nature of the trail that's generated. In the 300 megahertz to 3 gigahertz range, people do hydrogen and OH drift scanning. In other words, they set up an instrument and measure the change in the generation of waves, depending on where the circumstance is above your station. Spectral scans, and you can also tap into a lot of extraterrestrial satellites without breaking any rules, and that's always quite an interesting thing to listen to as well. And above that, in the 3 to 30 gigahertz range, there's something called the Itty Bitty telescope that's been developed by some folks in the educational side of things, and of course people get interested in SETI as well. And I was reading a new paper just a few days ago about people doing an appreciable job of monitoring the hydrogen in the system with a dish that's no bigger than about a meter in diameter. The antennas, of course, are the critical thing as far as radio astronomy is concerned, now that the electronics has been simplified. And antenna size is inversely proportional to frequency. So hydrogen emissions are at 1.4 gigahertz, and their wavelength's about 21 centimeters. And so a half wave dipole antenna is only about 10 centimeters long, quite a small antenna. Investigations of solar activity is normally carried out at about 28 to 30 megahertz, and a half wave for that frequency is about 5 meters long. So that's not a dreadfully long horizontal wire dipole either. Satellite TV antennas are also used for simple studies of galactic emissions, and homemade horn antennas are also used for these studies. And for meteor studies, people usually use Yagis, which are similar to the old-fashioned TV antennas that you've all seen before. Magnetic loop antennas are used for longer wavelength. These are basically large diameter coils, which are held in place with a little wooden structure, typically about 5 feet across, and the occasional whip antenna is also used. So there's a whole variety of tools that can go along with the software-defined radio and the precise amplifiers and filters and so on that I mentioned before. The principal limitation compared with visual astronomy is that the resolving power of a reasonable amateur radio telescope is an order of magnitude, several orders of magnitude below optical instruments. So you want to look at a cluster with your optical instrument, you can look at it and see it. You won't be able to find the cluster with your radio telescope because the bandwidth is in the 20 to 40 degree range. I mentioned before, a radio telescope is essentially a single pixel sensor, so people map the sky by moving this very broad antenna around and recording effectively a density diagram of radio transmissions in the sky. Some people have experimented with interferometry, a synthetic antenna size simulated by using multiple small antennas, using GPS clocking, because the timing is the most critical thing, but the complexity goes up substantially. I wouldn't be surprised if in the next few years, amateur radio astronomers will actually have that aspect figured out as well, and we'll be routinely getting better precision on the radio antennas by using two or more that are linked together. Just to close this presentation, I've got a series of resources that are worth looking at if you're interested. The Society of Amateur Radio Astronomers, which is the biggest group in the States and has a couple of meetings each year, publishes papers on this subject, and there's a real treasure trove of information about radio astronomy. NASA's Radio Jove, which was a project that was put together as an educational project for schools and universities, but which is carried on. UK Radio Astronomy Association, they actually sell a bit of gear, although looking at it today, I don't think it's particularly up to date. I think you can almost do better yourself by buying a couple of boards locally and wiring them together. The Canadian Centre for Experimental Radio Astronomy is a very interesting website to look at. They're located up near Ottawa, and they have done some interesting things. The National Radio Astronomy Observatory in the States and the Dominion Radio Astrophysical Observatory in Canada are also sources of information. So that's all I wanted to say. Randy, if anybody has an interest in playing around with these areas, please contact me and we'll see if we can do a few things together. Thanks very much for your attention. Any questions? Is everybody asleep?
I got a question.
I'm unmuted.
Yep.
Question.
Yeah. Is that okay? You mentioned meteor going by, you get a bounce of a distant signal of TV or radio.
That's right.
How long does that effect last?
Oh, anywhere from a few seconds to maybe a minute, minute and a half. So basically what people do is they use an SDR's, what they call waterfall screen, which shows across maybe a 10 megahertz bandwidth. It shows which stations that you're actually receiving as a bright light on this screen. And you'll see that a station which doesn't exist all of a sudden will come into existence with a bounce on a meteor trail and then go out of existence again. And then people take the record, because it's possible to record these things, take the record of these bounces, and they do fun things with them to try and work out something about the meteor in question.
Cool. I remember when I was a kid, I used to, like at 2 o'clock in the morning, this was back when there weren't as many TV channels, I guess. I was able to pick up TV stations from Florida.
Yep.
Because you get an odd bounce, but it lasted much longer than that. So I would assume it was, different ionospheric effect.
Yeah, it's probably different conditions, but who knows? But the ones that I've heard quoted typically don't last more than about a minute or two.
Cool. Thanks, Sean.
Yeah, it seems to me that at late at night AM stations from far away could be picked up really easily.
Yep. You got to be a
Ionosphere.
little bit cautious because as you saw from that figure of the planet, once we're into the nighttime period, the ionosphere goes from the 4-layer to a single layer, and that enables you to listen to things a lot further away than you could see during the daytime or could hear during the daytime.
Any other questions for John?
What I'm proposing to do, Randy, is I'm going to carry on and do a few experiments, and if they look interesting, I'll come back and talk to people about them.
That'd be great. I know that there are other people around who are doing interesting things like this, and it would be kind of neat to have some sort of demonstration equipment that we could use at public outreach, just to show the difference
Yeah.
between.
Bring a horn antenna out and hook it up to your computer and let the general public see
Sure.
the bounce.
Yeah, no, I know
We could put together an itty.
A bitty telescope, yeah.
Yeah, no, Paul Mortfield has had a little detector in his house for quite a while for capturing solar events, and of course he studied at Stanford solar astronomy, so he's well into this stuff. It's one thing I wanted to bring up, and I don't know if anyone has heard of Grote Reber before. John, you remember that name?
Yep.
He was an American amateur and picked up a lot of the work that Carl Jansky did in radio astronomy, but he was an amateur and he set up amateur stuff. He was a
Most of the earlier radio astronomy discoveries were done by amateurs.
he was an honorary member of the society. And I was going through files in the national office recently, and when I was national president back in '99, I sent a note out to all our honorary members, just inviting them to communicate and write an article for the journal. And I found a personal letter from Grote Reber that's in our files, just saying, hey, anytime you want me to come up and give a talk or whatever. He was kind of, elderly at the time, but it's neat that we've connected with an amateur like that who had an influence on radio astronomy. So
yes,
that's pretty cool. John, thanks very much. I'd really like to see us expand on this, because it's obviously something that most of us or all of us have not explored, but it's as you say, with new technology available, it might be kind of neat even just to capture basic radio waves.
Yeah.
That would be very cool. Thank you.
you're welcome.
Rick, you're up next with some photos of a recent supernova, I believe.
Yeah, let me share my screen.
Yep.
Are you seeing that?
I am. Go. You're good to go.
Okay, yeah, I'm going to share some astrophotography in my light polluted skies, which is pretty bad. It's Bortle 8. So I'm going to talk about 2 galaxies and a supernova. So just, I showed this before, but I should maybe go through it very quickly to show you my setup. I have a roll-up setup here. I'm not sure how to get rid of this little thing here. Are you seeing this? Are you seeing the full screen, or is anything blocked?
You look good.
Okay. So I have a rollout setup. So my Celestron C925 Schmidt-Cassegrain telescope, it's 9.25 inches aperture, and I run it at f6.3. It's on this homemade dolly, so I can just roll it out from my garage. I don't need any guiding with this mount. It's a CME 70 EC, so it's a very heavy and good mount. So I can just roll it out, and I can run for 1 or 2 minute sub exposures without any problem, with no guiding at all. I have a color cooled APS-C Astro camera from ZWO, and I do my acquisition with a Dell laptop. I actually have a home built rolling stand for that, which I roll out, but I only use this for alignment and focus. For my actual imaging, I have a 10-meter cable, a USB active cable, to my observation lounge, which is my car. And that's where I do my imaging from. So image capture and polar alignment are with SharpCap Pro software. The image capture part is free, actually, and it's very good. But you need to pay if you want the Pro version with the polar alignment, which I really like. I do all my image calibration, registration, and stacking in Deep Sky Stacker, which is free software and works exceptionally well. And image processing, I actually use Star Tools and sort of finalize things in Photoshop. Star Tools is a great alternative to PixInsight. It's really easy to use, but has a lot of powerful features if you want to do more. and it's much less expensive and again, a small learning curve. I actually shared some of my basic processing in more detail at the December 2021 Potpourri. So if you want to see the old videos, it's still up there. You can see more details on that. Now, because of my light pollution, I'm doing narrowband filters for pretty much everything now. I have two filters, the Optolong L Extreme and L Enhance. Both pass O3 and hydrogen alpha. So they're really wonderful for emission nebula, but I'm using them now for pretty much everything, as you'll see, for galaxies and so on. So the L Enhance reduced the light pollution by about 13-fold. So it's really impressive. The L Extreme reduced it further by about 2.5 times. And these I measured this actual measurement. So it's a really big effect. And again, I talked in a lot of detail about both filters in August and September of 2022 Potpourri. Again, if you want to go back to that video. Okay, so my major project this spring and early summer in May and June was the Whirlpool Galaxy M51. And this is my image here. This is actually more time than I had really initially planned to do, but I started out using the L Extreme filter and then decided I should add some L Enhance because that brings up some of the, particularly the blue regions much better than the L Extreme. And so in the end, I ended up with 55 hours, which is the image I'm showing you here. It's at 25 million years away, light years away. It's actually quite bright because it's an intrinsically bright galaxy. And it also has a spectra that shows strong hydrogen ionization emission lines. So there's a lot of ionization of gas in this galaxy. So it's known as a safer galaxy. And because it's so active, it has many of these red H2 regions, which you see very well coming out in this image. And those are regions that have a lot of ionized hydrogen and really intense star formation. It's called a grand design spiral because of these really nice spiral arms. And that's actually because of the interaction with this dwarf galaxy, NGC 5195, which actually right now is slightly behind M51. But what's been happening, it's been circling, orbiting around M51 for maybe hundreds of millions of years. So it's a long-going interaction. And it's these type of interactions that result in these nice spiral arms and all these really active regions. It's also kind of special in that it was this galaxy that William Parsons was the first to see spiral arms in a nebula. And he viewed M51 in 1845 with a 1.8 meter telescope. So visually, it's not that easy to see the spiral arms, but he was able to identify them. Of course, at that point, they had no idea what these were. And it wasn't until much later with Hubble and the Cepheid variables that it was realized this was really distant and therefore outside our galaxy. Now, I didn't want to discourage people because I'm always showing 30-hour exposures, 55-hour exposures. You can do a lot in a single night. And so I wanted to show that. So on the left here, this is one night with 3.5 hours. And my L Enhance filter. And you can see you get a very nice image with detail and H2 regions and so on. On the left-hand side, you can see you pull out a lot more detail. You have a lot less noise. You get a much brighter image with more color and faint nebulosity. All of these things are degraded by noise. So the increased exposure really is just about reducing your noise so you get a clearer image. And you can see it's pretty significant. And I guess I'm kind of a perfectionist, so I like to keep pushing in until I figure, well, I can't make it any better. So, but I want to encourage you, you can do a lot in one night. Anyone, can do this once they learn how. Okay, so while I was doing M51, we came with this amazing supernova in in M101 in the Pinwheel Galaxy. And so I had to absolutely try to capture it. So I managed 4 nights, 12 hours with my L-enhanced filter. I actually had taken another 12 hours, but as you recall, I mean, I had some problems with the full moon, but also there were some nights with some wildfire smoke. And this is a really faint and difficult galaxy. It's not an easy target at all. So you really need good conditions. And I just had to leave out some of the data because it wasn't adding to the image at all. It was, making things worse. So I ended up with 12 hours of usable data. So I really could have used a bit more exposure on this one to get the fainter part of this really nice spiral galaxy. So it's a similar distance away. It's 21 million light years. It actually has 6 companion galaxies. There's only one that's visible in this image, and that's this one here at the left-hand side. But these companion galaxies, which are outside the field of view, all of them combine with their gravitational and tidal forces to compress the hydrogen gas, which triggers the star formation, actually makes the spiral arms develop well, and also creates, in this case, nearly 13,000 H2 regions with ionized hydrogen that have been identified. So, and that's just the ones that have been cataloged. So it's a really impressive galaxy with all these H2 regions. And in fact, some of these H2 regions are really bright, and they so bright and large that they have their own NGC number. Now, the other interesting thing with this galaxy, which you also see to some extent in M51, is what's called Vorontsov-Valyanomov rose, commonly known as VV rose, because it's very hard to say their names. And what this is, if you follow these spiral arms, it's kind of neat. They're straight lines. So you get a straight line, and then it angles about 120 degrees to another straight line, 120 degrees to another straight line, 120 degrees to another straight line, 120 degrees to another straight line. So you can follow it in the series of apparently linear spiral arms. And this is, again, it's a transient feature that's a result of the hydrodynamics in the galaxy, just the way the gravity of the spiral arms interacts. And many galaxies will show this at some point in their lifetimes. Okay, so where's the supernova? So if we zoom in, the supernova SN2023 IXF is this bright blue star right here. It's right beside this H2 region, NGC 5461, this red splotch right here. And that's not surprising because this H2 region has, from the Hubble Space Telescope, it shows it has many massive young star clusters. And within those star clusters, there are many supergiant stars whose ultimate fate will be to turn into supernovas. So it's really not surprising this supernova is associated with this H2 region. This supernova is actually a type 2 supernova, and that means it's got hydrogen in its spectrum, but it also means that the reason for the explosion was that the nuclear fusion at this point in the lifetime of this supergiant star was too weak to prevent the core collapse under its own gravity. And so it collapsed, and then this resulted in the explosion and the expulsion of a lot of the star. The origin, it looks like, might be a 15 solar mass red supergiant star, although that has yet to be confirmed. Now, the other really cool thing about this, and we just heard about the contribution of amateurs. Well, this is a place where amateurs are contributing a lot, because this supernova was discovered on May 19th by the Japanese amateur Koichi Itagi, and he apparently is the most prolific supernova hunter. That's according to, there's a very interesting recent science article that shared a summary of his accomplishments. And it turns out later that some other amateurs found they had captured the onset, which was a day earlier on May 18th. And as well, other amateurs saw the rise of the supernova from magnitude 22 to 15 in about 33 hours. So all the really interesting, relevant early data came from amateurs in this case. And I did manage to find a light curve for the supernova. And so this is the magnitude plotted versus the date. I actually started my image on 5/24 on May 24th, where the magnitude was about 11. And at the end of this chart, 6:03, so June 3rd, it's still very close to magnitude 11. So it really has not decayed very much, at least at the start of June. I actually imaged until June 24th, but it really still is showing little apparent dimming. I had this vague idea of maybe, plotting the data versus time, but unfortunately during the month or so that I recorded the images, it really didn't change in intensity. So it rose extremely quickly in brightness, and then it's really plateaued. And unfortunately, I don't have a light curve that's more recent than early June, so I'm not sure what it's done recently. So that's all I want to talk about today. I'll just show, in case anyone wants to go back into the video later, this is the data on my the optolong filters, which I'm using for my work. So anybody have any questions?
Beautiful pictures, Rick. Roughly,
Oh, thank you.
roughly where are you at geographically?
Oh, okay. Yeah, I'm at Winston Churchill and Dundas.
Wow.
Yeah, so I just imaged from a driveway, and yeah, it's pretty bad because I'm on a corner lot, so I have a light right on my yard, in the front yard by my driveway, although there's a tree in the way, fortunately. Yeah, so it's under terrible conditions with these filters. I mean, they're really, really impressive, really impressive.
Excellent. Thanks a lot, Rick.
Yep.
Always impressive. We appreciate your presentations.
Thanks very much.
Yeah. All right. So we're looking at Starfest 2023. So John and Leslie, co-presenters. Are we coming up to the 30th anniversary or 40th anniversary of Starfest? I think Betty and I were at the 1984 Starfest. So what does that mean? John there? There he is.
Unmute yourself, John.
John's not talking to us.
John knows that he's muted, right?
Yes, I knew, but for some reason, oh, now I've stopped sharing. Ah,
Is technical.
thank God we practiced.
Yeah. Thanks for coming on early and practicing so that this would happen. You predicted this, so.
Yeah, I know. Sorry, can everybody hear me and see the screen?
No, can't see a
No.
thing.
Oh, no. Screen
Not a
share's
bloody
not-
thing.
We can hear you.
Okay, how about now?
That's better.
Good, John.
Okay, sorry about that. No, I had it full screen and for some reason, my controls all disappeared on me and I had to minimize it to do that. And then
Wow.
I had to share it as a result. So anyway,
So
yeah.
do you know if this is the 39th Starfest this year, or have they said anything?
Oh, 39. Wow. I started going in 2000, I think was my first. So,
Yeah, no, I remember going to the 84 Starfest, so
Yeah,
going since then.
wow.
Anyway.
Yeah, anyway, a lot of Mississauga members go to Starfest every year. And what we've done for the last, oh God, I don't know how many years now, 10 years maybe, is you know, we do our best to try to get together for camping and to camp together. I mean, first of all, I'm jumping ahead of myself because some of you may not even know what Starfest is about. Let's go through a couple of slides here. Okay, Starfest is a star party, camping weekend or week at a relatively dark location, only 2 hours drive from Mississauga. It's a safe environment for astronomers and their equipment, and everyone there is a science-loving geek. And if you're not, you're in the minority. So it has strict rules regarding lights at night. In other words, if it is clear enough for observing, you can't have any white lights. Otherwise, you will probably be killed. We have astronomy-related presentations during the day. Also, we have local vendors and manufacturers selling their wares. We have swap tables, fabulous door prizes after the last talk on Saturday night. And I'm not exaggerating, actually. We've actually had Mississauga Centre members, I think twice over the years win major prizes. You know, basically, tell us when. Generally, it starts on the Monday of that week and it ends on the Sunday morning. However, the key dates are the Friday and the Saturday. That's when you have all the major presentation and when most people arrive. Where? The River Place Campground, Ayton, Ontario. This is just northwest of Mount Forest, Ontario. And as I was saying, it's up Highway 6, about halfway between Mississauga and Owen Sound. Maybe I shouldn't say Owen Sound. It makes it sound further than it is. Okay, here's a map. So if we're in Mississauga, you're going up to 410, 10, Highway 9, Arthur, and then up here to just past Mount Forest to the River Place Campground. There's a little bit more of a close-up here. This road here is actually called, even though it's called something Road 9 on this side, it's actually Concession 12 on this side, which is kind of confusing, I know, but there's the Starfest people usually put up a sign here too that tell you turn left here for Starfest. So from Concession 12, that road we were just showing, you go down. I mean, here there's a nice big sign up here. You just go down this road. This is about, I think, less than a kilometer here, and this is the entrance to the park. And then you, for those of you camping, you can drive right into the area where, you know, close to where the action is. Although this whole thing is River Place Park, actually, all of this. So there'll be people all over the place. The main tent is down here somewhere though. And our group, we like to park around here. Now, this isn't an up-to-date photo, but there's other ones coming up as well too. So if you camp or pay for camping, you could drive right in. Otherwise, you have to park in this area here, and then you have a long walk down here. This is an aerial photo taken by a guy that goes every year. This may be out of date as well too. But once again, there's Concession 12 here, and then the road that takes you, and there's where we're coming in, and the main tent is right around here. Now, Leslie provided this this photo. I assume it's taken from a drone or something. Do you want to take over and talk about this, Leslie?
Yeah, I can. I don't know who took it, but it gives you a little bit more idea of where we will try to be. I'm going up on Thursday, and there are a few other people that go up on Wednesday or Thursday. And what we try to do is save a bit of space. And we park our cars further apart than they really need to be and that kind of stuff. And then as people come in our group, we fill that in. And when you come in, this is the main road that John said you would walk down if you had parked your car up at the main parking spot. You come here, and where you see this tree right here, I don't know if John, if you got that tree?
Yeah,
Okay, and you
I
can
think that's
show,
the tree you're talking. Can you see my cursor around the tree?
I can see your cursor, yeah. So then follow along the path that we take. It's 2 tire tracks in the grass. It's not a road. And you just follow it all the way along until you get where the road turns, which is a little further on, John.
Oops.
There. That's where we park, right where John has his cursor moving. Now, if you arrive, you know, Friday, late Friday or Saturday, there's not going to be any space there. I can guarantee it. In fact, last year it was really chock-a-block. So there are the space on the other side of that dirt path. You can see a car there with something orange on it, or is that a tent? The others, either that side where John is or the other side, as that's where you can park. The one issue with parking there is you may or may not have electricity. So just keep that in mind. So that's basically what it is. And this was taken probably on the Thursday, I'm guessing, because by Saturday, there is no green space. Even up past the tree where you come in, it's pretty full of people. Last year was exceptional in the number of people that attended. In fact, I've never seen it, and I've been going for probably 13 years or so now. It was packed tighter last year than I've ever seen it before. I don't know what this year will bring. Depends on the weather a lot, of course. So you can see, like, John, move your cursor down to that big area where, no, not down towards the tent, straight down. No, not, you're not going down, straight south.
South, oh, that way.
No, this, I can't show you. You can see where there's a whole bunch of people and it looks like a playing field or something.
Oh, here.
Yes.
Okay.
Those are the areas where they have the swap meets usually, where people bring stuff that they want to sell, and they just lay out tables and you can wander around, and there's all kinds of stuff for sale, from telescopes to little doohickeys that, you know, can help you do this or that. So it's worth going to have a look. And then the white tent is where all the talks are, the big white tent. And then past the swimming pool down at the bottom, off the screen actually, are where the washrooms are. And opposite the swimming pool, there's a building with an orangey colored roof. That's where the cafe will be, where they're selling coffee and snacks and burgers and stuff like that. And I think that's it as far as what the place looks like. Are there any questions on that while we've got this slide up?
Further to what Leslie said, yeah, basically, most of us are concentrated in here.
Yeah.
But then we've had people here as well too. I think Jose is up here somewhere. John Gola is always around here somewhere.
Yeah.
A few other people were along here. So we're really all over here, okay? So, and by the way, to walk from here to the main tent takes what, 3 minutes maybe? 4
Oh,
minutes?
yeah, it's not far.
Yeah, and there's porta potties almost everywhere. Like here, there's a couple here, for instance.
Yeah, I think this was taken early before they delivered the porta potties.
Yeah.
There's
Actually,
a lot more around than that.
yeah, there should be a lot more than that, actually.
Yeah.
So,
Absolutely.
yeah, and okay. Let's see what we have after this. Okay, the fees. Okay, there's 2 separate fees. You have to pay for Starfest itself, and the fee until July 31st $80 for an individual. After 31st, it's $100. So if you're gonna go, register by the 31st. If you have a family, it's about $40 more actually. And for youths, I assume this is youths coming by themselves, not as part of the family. 40 and 45 respectively. So, I didn't want to publish this here, but in the past, I think if you can't make it on a Friday, say you only want to come on Saturday, I think they'll charge you half price. But don't quote me on that or anything. No, just saying.
Yeah, it used to be afternoon on Saturday.
Only afternoon. Well, there's nothing happening before noon anyway, so yeah. Okay, this is the River Place fees, River Place campground fees. For an individual, non-camping, $20 a day, family, $35 a day. And that's where you park right near the entrance and you have to walk all that way. Camping fees aren't really a lot more expensive, only $3 more for an individual. So even though in my own case, I usually, I have back issues and collapsing tent issues. So, and I don't live that far. I live in Guelph. So quite often I'll just go home, but I'll still pay the camping fee just so to have the privilege of being able to drive up to where everybody else is. So, if you're just considering this now, this probably won't be applicable because it's probably all booked by now, I would imagine. I doubt if you'd be able to get a trailer in now, a trailer site now, but who knows? Same with hydro. Does that tend to be booked up in advance, well in advance, Leslie?
I think so, but I'm not positive because I've always bought it automatically when I register but hydro does get filled up. I can tell you that they spool hydro all over the campsites, and there's probably about 6 to 8 people that can actually plug into each little site, and they do tend to fill up. And I mean, there's a lot of people that are going up at Wednesday or Thursday who are basically astrophotographers, so they definitely need the power.
Yeah, along with Leslie, who usually goes on Thursday, Jose Alonso, I talked to him last night. He told me that he's going on Wednesday, so he'd probably be the first of our group.
Yeah.
Then, yeah.
He always tries to go Wednesday.
Yeah. And lots of great information on the Starfest 2023 website. Now, every time if I don't have the link handy and I Google NYAA Starfest or Star, I get the 2022 site for some reason. So maybe you might have to play around to make sure that you're in the 23 site, okay? But there's all kinds of information. Actually, let me just quickly show you that. I think I can launch it from here. I think Zoom is taking all my bandwidth. Oh my God, is that slow? Okay, so this is what the site looks. I mean, it's really good and lots of great info. Actually, that's a pretty decent picture they have here too. And this shows our area too, where we would be right around here. So anyway, yeah, lots of great info here, including to me, the most important is a program where it shows you the schedule of who's on when. To register, you go up here. If you're interested in seeing a breakdown of all the costs, click register, go in there, and then go into, oh my God, this is slow. And then just say that you're going to mail in so that you see an application. Yeah, download the registration form, and that'll show you all the costs at once without having to go through all of the questions. So, okay, minimize that again. What's next? Okay, but you think you don't like camping? Well, roughing it at the River Place includes a building close to the main tent with indoor flush toilets, sinks, showers, and hot water. As we mentioned before, many porta potties and hand washing stations all over the camping area, a heated swimming pool, The food truck open from early to very late, just for Starfest goers. And it only 15 minutes away is Mount Forest, where you have motels and all kinds of restaurants and stuff. Also Durham and Hanover are maybe 20-25 minutes away. Now, some important things you need to know. The weather, it can be hot during the day, but at night it's always colder than you think it will be. And, you know, I wouldn't rule out bringing a parka. Just
I always bring a winter jacket.
yeah, okay. Dew is formidable, starting at around between 11 and midnight. Bring or prepare to buy a red flashlight. It's I didn't mention this, but it's very dark at night, especially if you just come out of the lecture hall and you know where it's quite bright and you come out and it can be really dark. So it's a good idea to have a red flashlight. If you don't have one, you can make your own by putting some red cellophane or something at the end of the flashlight over the bulb. And or you can buy nice ones there at Starfest itself. And
Can I just interject, John, for a minute, because you were talking about the red flashlight. If you're going to park in the campground and you intend to go out to a restaurant at night or something and you're coming back at night, you must cover all your lights when you hit, you know, the entrance with red paper, and they will give you red paper as you sign in. You know, if you're going to do that, because, you know, if John is quite right when he says if you shine lights, white lights, they will kill you. Well, they actually won't exactly kill you, but you will certainly get shouted at and yelled at and called some nasty names. So it's very, very important not to have any white lights. Okay, John, back to you.
Okay, thanks. Yeah. Chairs for the lectures are not very comfortable. Okay, they're those folding chairs that have absolutely no back support. And some people bring their own chairs, or you know, if they're pretty compact, that is. I think Leslie does that, right?
I do that all the time.
Yeah. Okay, this is a suggestion from please remove hats while you're in the lecture so other people can see. There's group pictures. There might be one that Starfest takes by itself. I can't remember if they even did
I think
that.
there is going to be one.
There is going to be one, yeah.
I think so.
And this is a big effort, but we usually do our own too. And we usually have 20, 25 people, 30, whatever, although not all of them show up. And, you know, we'll pick a place and say, we're going to do a group picture sometime on the Saturday at 4 p.m. And the reason we pick 4 is that the banquet, by the way, there's this wonderful banquet too that they have every year, except they didn't have it last year. And of course, we didn't have Starfest at all for 2 years because of COVID before that. So it's pretty nice. They do a really nice job. They turn the lecture hall tent into a banquet hall. And I think it starts at 4:30, but you need to start lining up at about 4:50 so that we can run and grab a table for everybody in our group.
Yeah, I think it's 5 o'clock, John.
Is it 5? I couldn't remember the time exactly.
So
Okay.
we usually line up around 4:30. Well, right after the
Yeah,
group.
right after the picture, yeah.
Yeah.
Okay. Sorry, I got my times mixed up a bit. Some of us like to bring wine as well too, and remember to also bring glasses or something to drink out of. Oh, here we go. Line up 20 minutes ahead. I guess we should have had the time in there too. Okay, and I mentioned about the door prizes. You have to be present to claim a prize. And Chris Malicki did prove that this is possible because he was setting up for his observing by our campsite, and he actually made it in time to grab a prize once from where we were. So. Okay, here's the program. I just took screenshots from the website. Not much happens on Tuesday, Wednesday, Thursday. But if we go into Saturday, this is the stuff. I'm not going to go through every presentation here, but the key presentations Shedding Light on Dark Matter by Dr. Tony Noble. The Great North American Eclipse with Fred Espinac. He is, let's just say his nickname is Mr. Eclipse, okay? He was at Starfest in 2017 as well to talk about that. And he gave some great insights. He's seen many, many eclipses. So if you're even thinking of going to that next year to the April 8th total eclipse, you should target this. Okay, but there's a lot of really interesting stuff during the day as well too. So which is why I'm going to try to be here in time for this one here. That's my target. Oh, okay, that's the Friday. And on the Saturday, the keynotes, Terrence Dickinson tribute and Dr. Katie Mack with the map of cosmic time. And if you go to the website, there's actually write-ups on all of these talks. Oh, and here, I put a couple of them here. And by the way, this presentation is in our group's IO site, and I've sent instructions for how to get it. And this is Fred Espinac. Sorry, his name is cut off here. I don't know if you can see it or not. And Dr. Tony Noble. Okay, now I'm going to go into the subgroup to show some photos. Sure. Okay, for anybody who hasn't been in it yet, this is our groups IO website. To get into it, you go to this URL, and if you really don't know how to get into it, send me an email and I'll explain how to do that at some point. But basically, when you go in your first time, you'll be asked to establish a password, and after that, you shouldn't ever have to provide it again. So this is the main group. You can see all the messages ever sent to the group by clicking here. Oh boy, this is slow. Wow, now I regret clicking that. Okay, now there's other subgroups. There's subgroups within here, and I'm just going to go to, this is the one for Starfest 2023 that we just created for this year. If you go into here, and I'm not going to click it because it's too slow, at least on my computer. If you go into databases, that's where you're going to find a survey where anybody that thinks that they're going or is thinking about it or whatever, put in your information so that we have an idea. And this way, Leslie and the rest and myself will have a better idea of how many spots to save. So in the file section, you'll find this PowerPoint presentation, the same one that I just showed. I'm going to go into Starfest 2019, which is the last time we had a full Starfest that we actually uploaded pictures into. I don't know what happened to the pictures from last year, but this will give you a nice idea if it ever opens. Okay, here we go. This is our table at the banquet from one end. There's Wendy and Sheila. So this is some of us there. Liz and Brian. There's the main tent from the outside. This is inside the tent. So you can see it probably holds a good 300 people. So there's Terrence, Chris Malicki, Steve Malley. Steve Malley, I don't know if he's going to this year, but he always has a vendor set up there. This is where the food stand is. We won't talk about this one. Okay, this is us lined up to go into Pebbles. Pebbles is a really nice Mennonite-run buffet restaurant in Varney, which is about maybe 15-20 minutes drive away. And a bunch of us go here on the Friday, actually. And this is us at Pebbles. And here we are gathered around the solar telescope. There's Gord. I don't know what he's pointing at, but. Okay, this was our group in 2019. And this is more of our people here. This is that same table at the banquet from the other end. And I think that's it for my presentation. Leslie, do you have anything else to add before we open it up to questions, if we have any?
No, I don't think so. But if you think this is interesting, try it. And, you know, we do have a lot of fun. There's a lot of social time. You get to meet people and talk to people that you don't have a chance to these days because we don't meet all that often in person. And you can't really chat the same way over Zoom. So it's very good from a social point of view, as well as the talks are very good. You learn something from them. And then, you know, you can do your thing in the evening. And if you don't have a telescope, there are a lot of people around who will let you look through their telescopes, including usually one that is 36 inches across or 24, I can't remember. It's big.
36,
right?
yeah.
But lots of people will show you views through their scopes, and you can just chat to them, sit around, talk astronomy, talk whatever you want. There are a number of people who do astrophotography that are there. There are people that are working on, you know, some of their certificates, RASC certificates as well. So there's just a lot of stuff going on. And one other thing to keep in mind is that you will not get a lot of sleep. So be prepared to, you know, make up for it when you get home.
Unless it's raining.
Unless it's raining, of course.
Yeah.
Well, we don't talk about
that.
rain. We do not talk about rain. But bring a raincoat just in case.
Or tornadoes.
Or tornadoes, yes.
Oh, come on. They hardly even came close to the tornadoes.
Oh, it wasn't that far away, John. I lived through that one. It was not that far away.
By the way, if you are afraid of bad weather, don't go on the Thursday because those events always happen on a Thursday. Oh. Okay, now, once again, if you've never been, please make sure that you're subscribed to our Starfest 2023 subgroup. And I've sent out numerous emails about how to do that. I might send one more to the main group, okay? And please do that. Reach out, send a post, and because I would say maybe half of the time when somebody goes for their first time, they end up saying, I couldn't find you. So, you know, it takes some preparation. And I mean, on that survey that's on the website, sorry, that's on the Groups IO site, I have this place for people to put their cell phone numbers. Mine is on there. You could call me, except I don't get there till Friday morning. So, but if you're going to get there before Friday, then it shouldn't be much of a problem. Okay, because, you know, it shouldn't be that crowded yet, I would think.
we do also have signs, and there will be one up. Last year it was just attached to my car, and that's probably what we'll end up doing again this year, because we don't have any proper places to put it. But so if you go along that dirt road, you will see a car that has the Mississauga sign on it, and that's the area we're in.
Yeah, and you know what? If you're anywhere near that area, if you just ask anybody, we're the Mississauga people, that it's a really good chance that someone will know where we are. So. And I think that, okay, are there any questions?
Okay, thanks, John and Leslie. Any questions? Starfest.
Yeah, anything put you to sleep or an anesthetic type. Unless
It's
you
possible to
don't
make a
think
comment.
about way of putting it.
I think the anesthetic for some people, I
The
did.
anesthetic, in both cases, the hysterectomy and all that business, Barb and I found, it takes longer to get over.
What was that?
I don't know, but I muted it.
Weeks. And
Any-
it's just strange.
Any questions for our Starfest people? Okay, look forward to seeing some pictures from Starfest in September.
Yay, guys.
Look forward to some clear skies. Okay, well, that's the end of our program. Thanks to all the participants and presenters. And I'll post this tomorrow so that if anyone missed any of the parts of it, you can review, or if anyone wants a review of the Starfest plans, you'll be able to pick it up. So thanks, everybody. We have a Riverwood event next week, so I'll send out another reminder to everybody to come on out. The support has been great this year, and we'll look forward to another great evening at Riverwood. Kirby, do you want to say a few words about the event tomorrow night?
Yeah, a couple of you had signed up for potential members dark sky viewing this weekend. So tonight, we're not doing it tonight, obviously, but tomorrow night looks questionable, but I'll keep an eye on it. So just watch for an email, one more email from me sometime tomorrow that will confirm whether we're a go or not. And if you haven't signed up, it's no problem. You can still come. That's not a big deal. So we'll keep our fingers crossed. Maybe we'll get lucky tomorrow night. Otherwise, the next members observing night will be in the new moon weekend of September. We skipped October or August because that is the Starfest that we just heard about. So that's the new moon weekend in August. So September will be the next attempt if we're not successful tomorrow night.
Yeah, it's interesting that Starfest is the weekend of 18th, 19th, 20th. And the Perseids are the weekend of the 12th, 13th. So if anyone is interested and the weather looks good on the 12th or 13th, you might want to head out and find some dark skies and around midnight, see if you can catch some Perseids. Okay, and of course, weather dependent. That's why we all love astronomy, right?
One thing, John, the pictures from 2022 are up in Groups.io. I posted it in the address in the chat box.
Okay, actually, did you, I went through them, that they're just odd pictures. They're not really photos of the event. So they're just, I don't know. I don't know what they are. I was looking at them last night and I said,
What are they pictures of, John?
oh, just things like screenshots of things of the whatever. They're not the same thing as what we had for that 2019.
Oh,
Yes, they are. I'm
Are they?
looking at them now. There's people talking around.
I think it's your internet, John.
yeah, you got to
My
work on that,
internet is
John.
fine.
Okay.
I'll have to check them out then. Again.
All right, well, thanks, everybody. One way or the other, hopefully get some clear skies given this strange weather, but thanks again to the presenters. Good luck to everyone going to the Vinland tomorrow night, and we'll be in touch. Take care.
Bye.
Thanks. Good night.
And I-
Thanks, everybody.
Take care. Bye now.
Bye. Good night.